and P and Q are function of X or constant. Okay. Now this, if you have one equation, dy dx plus py equal to q in this form, then you have to find out the integrating factor. No, integrating factor is e power integration of p dx. Okay, so we should know. Shadia, Vishal joined, Chandan also joined, Babul did not join today. So Naburashi, Shadia, 1 minute, Shadia, Vishal joined. No? So that the integrating factor, you have to find out P and Q, value of P and Q, and then the integrating factor. Integrating factor is e power integration of P dx, and then that you have to multiply. Okay, no, what is the solution of that one? We run y into integrating factor, integration of q, integrating into integrating factor dx plus c. No, you are differentiating this one q integration of p dx. You are integrating this one with respect to x. No, x. Now I think that one problem is given. Already you have done. Okay, I forgot to tell you this one. Linear equation of first order, also known as Leibniz linear equation. Leibniz apostrophe s linear equation. Leibniz linear equation. It is also known as this linear equation. Okay. So I have given two problem here. First one, did you solve earlier? Previously, did you solve? X plus 1 dy dx minus 1 equal to e to the power 3x x plus 1 whole square. We have done this problem. Did you remember? We can do quickly also. It is very few lines only. Okay. So you have to find out here P and Q, then integrating factor. Then our solution is the y into integrating factor equal to integration of that q into integrating factor dx plus constant. Okay. If you have already done, still you can do this second time practice. You can do that one. We are starting from we already discussed linear equation. So today we came to know linear equation of first order, also known as Leibniz linear equation. Okay, here I gave two problems. We can solve that one. Then we'll learn the Bernoulli's equation. What is the meaning of Bernoulli's equation? We can solve the differential equation using separation of variable. If it is in the homogeneous form, you have to consider y equal to vx. Then we can use the separation of variable. Okay, and then linear equation of first order. Okay, linear equation of first order. Then Bernoulli's equation we'll learn. Okay, exact differential equation. What is the meaning? And if the equation is not in the homogeneous form, then how to make it homogeneous form. So these are the topics we have to cover. Are you doing that one?
Yes, ma'am. Yes, ma'am.
Last time I think last Wednesday I gave some 5 problem or 6 problem, no? So I received from everyone, but Arnav, you didn't send.
Yes, ma'am. Actually, that day, the next day at exam, I forgot to send that, and I got the message later. Sorry, ma'am.
And I think Shatish.
Ma'am, can I send it now?
You can send me. Shatish also. I think Shatish also I didn't receive.
Ma'am, I send.
You send? Okay, late actually. Okay.
Yes, ma'am.
But Arnav, you will not get the attendance for that day.
Okay, ma'am. Sure.
Is it
No
fine
problem.
now?
Yes, ma'am. Yes, ma'am.
You have lot of attendance, no problem. If it is above 7, that will not carry any marks, above 70%. But in lab practical, you try to attend, because we give some marks for attendance, 10 marks. So practical class you try to attend.
Okay, ma'am.
I'm not handling any practical, but generally faculties are giving. Puruli is giving, I know. Sharad also gives. If you get, if every day you are present, you will get 10 out of 10. Done?
Yes, ma'am.
Okay, good. Okay. Everyone know?
Yes, ma'am.
Okay. So next problem you see. Okay. Next problem is that. Okay. So you write the equation in the form of, like, this equation is given. Equation is e to the power minus 2 square root of x divided by square root of x. Square root of x means all of you know x power 1 by 2 minus y by square root of x into dx dy. Okay. Equal to 1. Okay. 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 So write the equation in the form of this one. dy dx plus py equal to q. We write the equation in that form, and then integrating factor you find out. Whether you are getting the integrating factor e power 2 square root of x. All this problem I took from one book, Higher Engineering Mathematics. That is Grayal book. Some problem. If it is done, let me know. Got it? Got the answer? Or you need me to explain?
Got it, ma'am.
Okay. Everyone?
Yes, ma'am. Got it.
Rabia, Divya, Chandni.
Yes, ma'am, done.
Okay. I have some more problem. I'll bring the book. Okay, let me first explain that one. Bernoulli's equation. Then I may give you some more problem on linear or Bernoulli's. So when you can see the note PDF. You can see the PDF file that dy dx plus py equal to q dy dx plus py equal to q. That is basically Leibniz linear equation. No, when dy dx plus py equal to q y to the power n, and p and q are function of x, and irreducible to the Leibniz linear, reducible actually, to the Leibniz linear equation and usually called the Bernoulli's equation. Okay, so in this case, what we have to do, we have to we have to solve this equation, no, differential equation. So we have to first divide the both side by y power n. Okay, okay. So if you divide, you see that note. If you divide, then dy dx by dy dx, or you can write 1 by y to the power n plus p y divided by y to the power n equal to q. Okay, so or either you can write y 1 by y to the power n means y to the power minus n, no? So I have written that one. Let's see the equation 2. Did you understand the equation 2?
Yes, ma'am.
Okay, so equation 2. Okay, now see, means we are solving the Bernoulli's equation. Okay, we'll make it to Leibniz linear. Achha. Now, what we are doing, we are considering y to the power 1 minus n. This one, p into that one, that factor, p into y 1 minus 1, that we are considering as z. Okay, so if you consider that one is z, then what is happening? If you consider y y to the power 1 minus, up to 2, equation 2, all of you understood, no? Everyone understood? Up to the equation 2, that y to the power minus n dy dx plus p of y 1 minus n equal to q. This equation 2.
Yes, ma'am.
This you understood, no? Achha. Now we are considering, let us consider y to the power 1 minus n equal to z. Then what you will get? P into z you will get, no? Y into 1 minus n pz. Okay, so then what will be your equation? We are considering 1 minus y to the power 1 minus n equal to z. Then the equation 2 will become, what is that? Oh no, sorry. Y to the power 1 minus n equal to z. So if you differentiate, what is happening with respect to x? Y to the power 1 minus n equal to z. If you differentiate with respect to x, then 1 minus n y to the power 1 minus n minus 1, no? If you differentiate x to the power n, what do you get? N into x to the power n minus 1?
Yes, ma'am.
Yes, ma'am.
That
Yes, ma'am.
we are considering y to the power 1 minus n equal to z. So see, we are changing, so we have to take actually dz dx. So that means we are y to the power 1 minus n equal to z. So you have to differentiate with respect to x. So if you differentiate respect to a both side, means y to the power 1 minus n equal to z, then what you will get? N into n, here n is 1 minus n. Okay, n into y to the power n minus 1, no? So here n is 1 minus 1. Okay, so we are writing 1 minus n, y to the power 1 minus n minus 1. So 1 and minus 1 will be cancelled. So we are getting 1 minus n, y to the power minus 1 dy dx equal to dz dx. We are getting?
Yes, ma'am.
Okay, then this one, if you substitute here, this equation 2, what you will get? So now our dy dx equal to dz dx divided by 1 minus n by 1 y to the power minus n. That we are writing, you see. if you substitute this one, dz dx, it means dy dx equal to this equation. If you substitute the equation 2, so we will get one equation 1 by 1 minus a dz dx plus pz equal to q. So this is a, can you say this again, then dz dx by p into 1 minus nz equal to q into 1 minus n. So can I say this is a Leibniz linear equation of z in z? What is the form of this Leibniz linear equation? That is dy dx plus p y equal to q. No. So can I write this one? So this is now instead of dy dx, so we are changing z. We are taking z. Okay. So this equation dz dx plus p of 1 minus nz, 1 minus n is constant, so it will not change anything. P into 1 minus nz equal to q into 1 minus n. P is a function of x. P and q are function of x, are constant, no? So this equation dz dx plus p of 1 minus n into z equal to q into 1 minus a. This is a Leibniz linear equation in z. So now that, how do you solve the Leibniz linear equation? Same way you have to do. So we are making to Leibniz linear equation, the Bernoulli's equation, and then you will solve as it is, like whatever we did for Leibniz linear equation. But whether you understood up to the last stage, last part, dz dx plus p of 1 minus n into z, q to 1 minus z. Whether you understood? Each and every one, Amol?
Can you repeat from the step? Put y power n is equal to vz.
Y power 1 minus n equal to is z. No, that one is it you are telling.
Yes.
So we
Yes,
are
sir.
considering this one. Let us consider y, like substitution we are doing now. Some function like tx. That way we are doing y to the power 1 minus n. See, we have p into y to the power 1 minus n we have. So we are considering y into 1 minus n, means sorry, y to the power 1 minus n equal to z. So if you differentiate this one, y to the power 1 minus n equal to z, then what will happen? Just differentiate with respect to a. So
Okay.
what you will get? So what we will get? Y to say we have y to the power n. So if you differentiate, what we will get? N into
y power
y
n.
to the power n minus 1
Yes, ma'am.
into dy dx.
Yes,
Okay.
ma'am.
So here n is 1 minus n. No, here y to the power 1 minus n. That formula we are using.
Okay, ma'am.
ddx of x to the power n. That formula we are using. Okay. So we are differentiating with both sides with respect to x. So now left hand side, did you understand? Why it is 1 minus n, y to the power minus n. Actually, y to the power, when you are differentiating, that will be y to the power 1 minus n minus 1. N minus 1, no? Here n is 1 minus n. So 1 minus n minus 1. So 1 minus n minus 1. So plus 1 minus 1 will be cancelled. So basically we are getting 1 minus n y to the power minus n dy dx, and right side is dz dx because we are differentiating with respect to dz dx, so with respect to x.
Yes, ma'am.
Now see, now from this equation, like 1 minus n y to the power minus n dy dx, from this equation what will be the dy dx? So left side you want to keep only dy dx. Then what will happen? Just left side you want to write dy dx. So this part 1 minus n y to the power minus n will go right hand side.
Yes, ma'am.
So what will happen? Dy dx equal to dz into dx into 1 by 1 minus n into y to the power minus n. Why we are doing this one? To substitute dy dx in terms of dz dx. You have to write no in the equation 2 to make it Leibniz equation.
Yes, ma'am. Got it.
Everyone, that Amol, Arnav, did you understand? I hope.
Now I understood, ma'am.
Yes, ma'am. Understood, ma'am.
Chandan and Chandni. Chandni should understand. Chandni, shall I request one thing? You use that one, that white paper. Okay, that ruled one, and some pen you are using that when you are you are scanning. No, that is not clear actually. That last statistics exam also I noticed. For me, it is very difficult to read. Very light. So, okay, some Chandni until. So you use some different pen. It is very light. I think you are using gel pen. I don't know why it is. It is very light one. Even this assignment you submitted, no, also. No need. That there is no mark. If it is, I saw it is correct only. Okay. So now, how many of you understood that equation 2 is becoming this one? 1 by 1 minus 8 dz dx plus pz equal to q. Like I just
Understood, ma'am.
Understood.
Understood, ma'am.
then final one, how it is becoming Leibniz linear equation in Z. So, the last line, dz
Yes,
dx.
ma'am.
Okay. So now can you solve without seeing that one? Can you solve? Okay, no, sorry, there is one problem actually. This is just the procedure. Okay. Now see, we have x into that next problem you see. Next problem, that one problem I have given. So x into dy dx plus y equal to x cube y to the power z. Okay.
Ma'am, that's 6 only, no? X, Y power 6.
Y power 6, that one. You have to make it Leibniz linear equation in Z. Up to this one, Leibniz linear equation in Z, you can see the file, the note you can see, then you do yourself. Finding out integrating factor, you have to do it without seeing that one. But you see how I make it Leibniz linear, convert it to Leibniz linear equation. Let me see from the book some more problem. Actually, second order it's not there, but we should learn. We are just learning first and first degree. Okay, next semester, when I modify the syllabus, I'll add. You should learn the higher degree also. Engineering, mathematics, everything is there. Achha, I am adding one problem. It will be difficult for you. Okay. Chat box so how many of you understood? Means up to this one, Leibniz linear equation, anything I have to explain? Should I explain anything?
Ma'am, in this solution, we will be using the same formula, right? Like e to the power y e to the power integration ptx like that. Okay.
Factor, integration of q integrating factor dx plus constant. Same. That's why that we are making it to Leibniz. Then that same method we are using to solve the equation. That Bernoulli's equation, I wrote na dy dx plus py equal to q to the power 1 y to the power n. So where p and q are function of x and it is reducible to Leibniz linear equation. And that is called Bernoulli's equation. Reducible, that's why you are reducing, means we are changing actually to Leibniz linear equation. And then we are solving. We have learned how to solve the Leibniz linear equation. Leibniz spelling is Leibniz. Amul, did you understand?
Yes, ma'am, I understand. I'm doing it.
How many of you have completed? Let me give here chat box. I'll type more problem, but I'll not give the solution. You have to try yourself. dz by dx plus z by x log z equal to z by x into g log z this is whole square then z by dx plus z by x log z equal to z by x z. This is one problem. Okay. Any steps I need to explain? This problem, current one. Hello.
Finished, ma'am.
Okay, everyone.
Yes, ma'am. Completed. Yes, ma'am. Completed.
Divya, Megha, Chandani. Any difficulty in understanding Shadia and Shatish? Shadia? Shatish? Do you,
Yes, ma'am. Done, ma'am.
Shatish, you have any difficulty? Can you write in the chat box, Shatish? Chandan?
Yes, ma'am.
Any difficulty in understanding? Have you
No,
done?
ma'am.
Did you understand?
Yes, ma'am.
Vishal? Vishal Nagura?
Yes, ma'am.
Got it? Answer?
Yes, ma'am. I got it, ma'am.
Okay. Satish is not replying anything. Achha.
Ma'am, I'm here.
Okay, now have you done? Completed?
Yes, ma'am.
Did you understand? Any step I need to
Yes.
explain?
No, I understood, ma'am.
Okay. So next one I have given this one. This is dz. The solution is not there. Means dz by dx plus z by x log z equal to z by x log z to the power x. Sorry, square. Your differential equation is dz by dx plus z by x into log z equal to z by x into log z whole square. Oh, someone is calling. 1 minute, huh? Someone is calling. This problem you try, I'll help you. Hello. Okay. This problem you try. Okay. Just I'll explain the concept of exact differential equation. You can do this one at home, this problem, but answer you write down. Okay. That finally you will get x into, shall I type or you can? Okay, x log z, okay, within the bracket you write x into log z whole to the power -1, to the power -1 means power -1, x into log z within the bracket to the power -1, x to the power 1 plus cx. Let me type, it will be easy for you. Answer is x log z, x log z -1, it's x log z, sorry, x log z -1 equal to x to the power, sorry, equal to 1 plus cx. See this one, whether you are understanding. X into oh, I'm wrong. Achha, this is no, I'm wrong. This is answer is control V. High now power that is increase actually. Go now. Not able to see anything with this spec. Log z whole to the power, answer is log z whole to the power -1. Log z whole to the power -1 equal to 1 plus cx. This is your answer. Log z to the power -1. Log z to the power -1. This is the power. -1 is the power. 1 plus cx. This is your answer. Huh?
Ma'am, x log z to the power -1, right? Not log z to the power -1.
No. You are getting that one.
No, ma'am.
Okay.
I'm asking the answer.
Okay, sir. Answer is this one. Next. Okay, I didn't post. See this one.
Ma'am, is it like x? Yeah, a log z. Okay.
I'm not able to see that. My power, I think I have to check up my eye. That log z to the power -1 equal to 1 plus cx. Log z to the power -1. This is the answer. Huh? Okay. So let me explain one new concept. Then I'll leave you. What's it? You have internal today?
No, ma'am.
No, ma'am.
No, ma'am.
So almost all internal is over. First internal is over.
Yes, ma'am. First internal over.
So can I make another internal for you? Then everything I'll shut down. It's close. Should take actually. 4th unit I'll give you all notes. I'll explain also. But from this one you want or integration one? Second internal, and when do you want? When should we conduct? This month I want to complete first and second both. Means first already over. You just discussed among yourself and let me know. Okay.
Okay, ma'am. Okay.
Exact differential equation. That page you see. I'll just explain how to do this one. So this equation, what is the meaning? So if this m and n, what is m and n? M is a function of xy dx plus n is a function of xy dy equal to 0. This will be, this is said to be exact if this thing happen. Okay, condition of becoming and exact means condition of getting exact differential equation is if you get del m by del y equal to del n by del x, it is the partial differential equation. Then if it is both are equal, then you can say this m dx plus n dy equal to 0. It is a exact differential equation. Okay, what is m and n? M and n are the function of x and y. Okay. So in that case, what will be the solution of this differential equation? Okay, you have to integrate m dx, m dx with respect, means you are integrating m with respect to x plus integration of terms, that part not containing x, into dy plus c. This is the, if any equation is in this form, means if you see del m by del y equal to del n by del x. Okay, what you say, the dow n or something you say, I think. I say del m by del y. If one means you are m and n, you are differentiating with m, you are differentiating with respect to y, and n, because it is a function of x and y, no? So you are differentiating y, m with respect to y, and dn with respect to x. Okay, n with respect to x. And the solution of this exact differential equation will be, you have to integrate integration of m dx plus the part, okay, not containing x into dy, means you are integrating the part that containing, that not containing x to dy plus constant. Okay, like see, I will explain this, that one problem is there, you see. Like first thing is, this is the equation 1 plus 2xy into cos x square minus 2x square xy dx plus sin x square minus x square into dy equal to 0. So m, what is m here? M is the first one, 1 plus 2xy cos x square minus 2xy. This is m, and n is sin x square minus x square. Okay, then you have to check whether this del m by del y and del n by del x is equal. Okay, you have learned the partial differential equation. You differentiate, you del m del y, you find out and check whether it is del and is equal to del n del x. You just check and let me know. Is it getting? Whether I have any problem here?
Yes, ma'am.
Getting, no? Everyone. So we got del m by del y equal to del n by del x. Both are equal. Okay, so it is an exact differential equation. Okay, so exact differential equation means we have to integrate m dx. M dx, so you have to consider y is, as constant. Then terms of n not containing x. Terms of n, I didn't write, no? Terms of n actually not containing x. Okay, so m is the, m already know what is m. So you have to integrate that one with respect to x, dx. Then, so terms of n not containing x. So n is basically sin x square minus, there is nothing, no? All terms are sin x square, x is there, minus x square, n equal to what? Sin x square minus x square. No. This is the procedure actually, method. Okay, terms of n not containing x. So n, there is no term, no? Sin x square, x square, both are containing x. So what you should do, that is that part equal to 0. So only you have to integrate m dx. Integration of m dx equal to constant. That one only you have to integrate. So that will be your solution. Whether you got it or not. If the equation is in this way, m dx plus n dy equal to 0, you have to check, you have to first find out what is m, what is n. Okay, value of m and n. Then you have to do the partial differentiation of m with respect to y and dn dx, del n dx you have to check whether both are equal. If both are equal, then this equation is exact differential equation. And that case, how to solve? What is your solution? That integration of m dx, considering y as constant, plus the terms of n. Okay, I forgot to mention that one, terms of n. So you know what is n, not containing x. So here in this problem, what is n? Sin x square minus x square. Is there any term not containing x here? You answer. No.
No, ma'am.
Sin x square minus x square, all term are containing x, so we will not get anything here. So we will omit, we will not take this one, means zero part. So just we will integrate integration of m dx, that is equal to constant. That is your integrate, you can integrate this one, and that will be your answer. Whether you got it?
Yes, ma'am.
Yes, ma'am.
And y, considering y as constant. Okay. So when you are integrating m dx, you have to consider y as constant. I have written, see, y, consider y constant. That is your solution. Whether you got it or not. So, shall I give you one problem, or tomorrow we'll solve? No, it will take time. Y square, you have to scan again. Y square e x y to the power y. No. I cannot write also here. Chat box. So many power is there. Okay. So see that what is the Bernoulli's equation? How to solve it? Bernoulli's equation, and how to, you have to make it to, you have to reduce to this one equation is Leibniz linear equation. Then we have already learned how to solve the linear equation. No? How to solve the linear equation, same procedure you will follow. And then what is the exact differential equation? Okay, that only these two concepts we have learned, Bernoulli's one and exact differential equation. So next class we'll solve, I gave only one problem from Bernoulli's equation. Exact differential equation tomorrow again we'll solve, and this part I will explain. And if you get time, equation how to reducible to homogeneous form, you just check. Okay. So we have already learned how to solve the homogeneous equation. If the differential equation is in the form of homogeneous, we know. Okay. Otherwise, if it is not homogeneous, how do you reduce it into a homogeneous form? So first part actually, if you get time, you can go through this one, only 1 and 2 pages. Okay. Is it okay? Shall I leave you?
Okay, ma'am.
Did you understand or not today? Any difficulty?
No, ma'am.
Understood, ma'am.